Now we'll use our trig ratios and our knowledge of solving right triangles to help us with some application problems. If you recall from geometry, you probably learned about the angle of elevation and the angle of depression and using those in word problems. So we'll do that now. So just take a quick review of this information about angle of elevation, angle of depression. Now keep in mind, I'm giving you a pretty straightforward example to work in this set of notes, but the problems that you'll be working in class and on the unit test will be much more involved and require a little bit more critical thinking than these particular problems. But this is a nice reintroduction or review to this material for you. So if we look at example number 4, we have a plane coming down. It's at a certain altitude. Now part of the skill that you're going to need is actually drawing what's being told to you. Getting a visual of this information and actually coming up with your own right triangle is important. And if you label it incorrectly or if you interpret the wording incorrectly, you may actually end up solving for the wrong thing. And so keep in mind, altitude means height in these triangle problems. And also if we're looking for the horizontal distance, or if we're looking for the horizontal run, these are the different types of languages that you could see in the particular problems. Keep in mind, angle of elevation and angle of depression are congruent, and that you're using it in the right place. So if you look here at example 4, you can see that we used both methods. We used the cotangent for the first setup, for the first solution here, and then we also used, in the second solution, we used tangent. So whichever is your preference, that's the route you would want to go. But this is basically the same thing that you've been doing in prior problems, just a matter of setting up your own triangle to start. So let's look at sample problem 4. Why don't you go ahead and take a look at sample problem 4 with the flagpole, work that problem, and come back and take a look at the solution. Okay, so a couple things here that we want to look at. It says you're measuring the height of the flagpole. Now, what I've done in this particular problem is I've already given you the visual, but it would be a good idea to get in the habit of learning how to draw the actual picture without having the visual given to you. Now, keep in mind there are certain things that you want to take account of, how the answer should be left. So if we say round it to the nearest foot, and you're putting it in decimal form, that will be incorrect. So now that we have a visual here, we have you standing 20 feet from the base of the flagpole. Remember, the base is down here where the bottom touches the ground. You measure the angle of elevation at 65 degrees, and so that gives us our parts. And so now we can see that a hypotenuse is not being used. Keep in mind, this height, h, is referring to the height, not the hypotenuse. So sometimes if you use variables that are similar to different parts of the triangle, you don't want to confuse yourself there. So we're going to use tangent in this case. Tangent is 65 equals to the height over 20, and then we can just solve that. And rounded to the nearest foot, that gives us 43 feet. Alright, so that should be just a good simple problem for you to kind of reintroduce you to these application problems. We'll work on some more challenging types of problems in class together.